Section 4.4 is about graphing linear equations or lines using a table. So there are 4 methods for graphing a line, and today we're going to discuss the first method, graphing with a table. We are also going to talk about how to graph a line that has only one variable, and those lines are either going to be horizontal or vertical. Then we're going to learn how to graph with the intercepts, plural, 2 of them. And then finally, we will finish the section up with graphing with using slope-intercept form. So those are the 4 methods you'll learn in this unit for how to graph a line. We have already, you might have already done this, but when you want to graph a line, okay, especially when it has 2 variables, we need to get y alone, which we have practiced previously in section 3.8, solving for a single variable. So if we wanted to get y alone, how would we get y totally alone? We need to move this 2 out of the way and this x out of the way. And lucky for us, we can move them both at the same time by undoing them. So we don't divide by -2 or divide by x, but we move this whole thing over by adding 2x to both sides. Now, when we did this section originally in 3.8, I told you could bring the variable down or the number down first, but we practiced bringing the variable down first. Now notice this is a whole number or constant. This is a variable. So these cannot be added together. So it's just a matter of what order to bring them down. So this is a positive 2x and this is a -4. So you're basically just bringing it down next to each other. So that's the first thing you need to do, is to get y alone. Once you have y alone, then we are going to make a table of values. Now we want to pick some points that are close to the origin. The larger points that we pick, the further away it will get from the origin, the bigger the graph we need. But we want to make sure that we include all types of numbers. So that means negatives, positives, and we always include 0. So generally when we make a table of values, we include one negative, -1, 0, 1, and 2. So these are generally the 4 values that we're going to choose, but there's one exception which I'll show you later on in the section today. So if we want to plug in these values for x, because we solve for y, this will be very easy for us to do. If you don't solve for y first, then plugging these values in causes you to do 4 times as much work. So if we solve for y once, now our equation is y equals 2x minus 4. All we're doing is taking that -1 and plugging it in for that x. So you do have to show 1 step of work. So we'll do 2 times -1 minus 4. I'll show you a couple different ways and then you can choose what you want. So if you just plug it straight in like this and then you do this in your head, 2 times -1 is -2, -2 minus 4 is -6. And then put the answer over here on the left side of the table. So you have the x and the y right next to each other, and that creates one of the points. So we can do that for all of them. 2 times 0 minus 4, 2 times 1 minus 4, 2 times 2 minus 4. And then make sure you always use order of operations to solve these. 2 times 0 is 0, 0 minus 4 is -4. 2 times 1 is 2, 2 minus 4 is -2. 2 times 2 is 4, 4 minus 4 is 0. Now these create our points, and all we need to do is graph these 4 points. -1, -6, 1, 2, 3, 4, 5, 6, plot that point. 0, -4, 1, 2, 3, 4. 1, -2, 2, 0. Now when you draw your line, I don't want a little squatty line like this. Make it go the whole length of the graph. That'll be more helpful when we get into the later sections in this chapter. Okay. All right, so that's probably the most basic, just having to move the one term over. Number 2 is a little more challenging because you have to do a couple steps before you can get y alone. So we want to get y totally alone. And just to refresh your memory, the 4 is going to move away from y last. Okay, remember the boyfriend, girlfriend. That's the girl and that's her boyfriend and that's the other couple. She's going to give up the other couple before she's going to let go of that boyfriend of hers. So we also, the piece there is that we always undo addition and subtraction first, and this is multiplication right here. So this we need to undo by adding. So we get 4y equals, bring the x down first, 4x plus 12. Then we need to get y alone, so we divide every single piece by 4. Y equals, you can write 1x if you want, or you can just write x. I'll write 1x this time. And 12 divided by 4 is 3. So here's our equation. This is what we're plugging into. So we're still going to use the same value of x's, negative 1, 0, 1, and 2. Remember, this is called, we haven't learned this yet, I don't think, but this is called the domain. So the domain for these tables will always be these, except for the exception we'll talk about here in a second. And then this is the equation we're plugging into, 1x plus 3. So 1 times negative 1 plus 3. Now, here's the thing. If you just cancel these out and just wrote x, then you don't even need that 1, and it may seem like one less step. So it really is 0 plus 3, 1 plus 3, 2 plus 3. Very easy. And I know this is simple, but you are still required to show one step of work for each of these. So it's not difficult. You just have to do it. So negative 1 plus 3 would be 2. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. Now you should see a pattern before you even graph it. Negative 6, negative 4, negative 2, 0. We're going down by 2. Or really, up by 2 because they're negative. And these are going up by 1. So you should recognize a pattern here, and then you confirm that pattern when you graph it and it actually creates a line. So negative 1, positive 2, 0, 3, 1, 4, 2, 5. And again, no squatty lines like this. Make it go a whole length of the graph until you get to the edge there. Why don't you try number 3 by yourself? See how you can do with number 3. It's just like number 2. So give number 3 a shot all by yourself. I'm sure you'll be fine on that. Okay, so we need to move the x away from the y first. So we add the 12x to both sides. 4y equals 12x, bring the x down first, minus 8 because it's negative. Then divide everything by 4. And we get y equals 12x divided by 4 is 3x, negative 8 divided by 4 is negative 2. Still choose the same domain, the x values. We get negative 1, 0, 1, and 2. And our equation is 3x minus 2. So 3 times negative 1 minus 2. 3 times 0 minus 2. 3 times 1 minus 2. 3 times 2 minus 2. So just show your one step of work, and now you can go back. Make sure you always follow the order of operation. So multiplication always happens first. 3 times negative 1 is negative 3. Minus 2 would be negative 5. 3 times 0 is, of course, 0. 0 minus 2 is negative 2. 3 times 1 is 3. 3 minus 2 is 1. 3 times 2 is 6. 6 minus 2 is 4. Now the pattern isn't as easy to see here, but we're adding 3 every time. So let's graph that. Negative 1, 1, 2, 3, 4, 5. 0, negative 2, 1, 1, 2, 1, 2, 3, 4. Okay? Hopefully that was no problem for you. Let's flip to the back side. Now here's where we get into the one difference I was telling you about. So let's look at number 4. We still need to get y alone. So we're going to move this 3x away from it. Now there's a couple different ways you can get y alone. You can move the 6y over and then the 18 back. Or let me show the other way. The quickest way is to get y alone would be to move the 3x over, and then I'll show you what to do with it. So we're going to add the 3x to get it away from the y. And remember, we want the x to come first. 3x plus 18 equals 6y. Our goal is to get y alone, so we divide everything by 6. Now here's the piece. We get y here, 18 divided by 6 is 3. But 3 divided by 6 is not 2, it's 1/2 x. Be very careful. We're dividing the top and the bottom by 3, which gives us 1/2. Now, since y is on the right side, we want to flip it all the way over so it's on the left side. Y equals 1/2 x plus 3. We still want the x to come first and the constant to come second. So we flip it so the y is over here. Okay. Now here is where your domain is going to be different. Because we have a fraction right here, we're going to choose, choose multiples of the denominator. And there's another way to think about this. So the denominator in this case is 2. So instead of -1, we take -1 and multiply by 2 and we get -2. 0 times 2 would still give us 0. 1 times 2 gives us 2. And 2 times 2 gives us 4. So we are still thinking about the -1, 0, 1, and 2, but we multiply each of those by the denominator. And that's where these numbers come from. So -1 times 2 gives you -2. 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. Now, why did we do that? If we do that, then we won't have to deal with any fractions. So let me show you. 1/2 times -2 plus 3. 1/2 times 0 plus 3. 1/2 times 2 plus 3. And 1/2 times 4 plus 3. Now, which one of these is the easiest one to do? That's always going to be your 0. So half of 0 is still 0, and 0 plus 3 is 3. So stick with the easiest one first. Now I'd say skip the negative for now, and let's go into the positives, and then you can come back and do that. Half of 2 is 1. So that was nice and pretty because of the multiples of 2 that we did here. So half of 2 is 1, and 1 plus 3 is 4. Half of 4 is 2, and 2 plus 3 is 5. Now you can probably guess what this one should be if you look at the pattern, but let's work through it. Half of -2 would be -1, and -1 plus 3 is 2. So 2, 3, 4, 5. You can see the pattern there. If we did -1, 0, 1, and 2, we're going to get fractions for half of these answers, or all of them, except for the 0. So when you have a fraction, you should be choosing multiples of the denominator. Let's go ahead and graph this. -2, +2, 0, 3, 2, 4, 4, 5. Graph that line all the way to the end. Okay. Now number 5 is going to be similar. I'm sure you can do that one on your own. Give that one a shot on your own before you look back. So in this case, the only thing we need to do to get y alone is divide everything by 10. So we get y equals, again, this is not 2x. If the number is smaller on the top, then it's going to come out to be a fraction. Divide the top and the bottom by 5, we get 1/2. And 20 divided by 10 is 2. So we have another fraction here where 2 is on the bottom. So we're choosing multiples of the 2. So -2, 0, 2, and 4. And we get 1/2 of -2 plus 2. 1/2 of 0 plus 2. 1/2 of 2 plus 2. 1/2 of 4 plus 2. Start with the 0. Half of 0 is 0. 0 plus 2 is 2. Half of 2 is 1. 1 plus 2 is 3. Half of 4 is 2. 2 plus 2 is 4. You can figure out what that one is, but half of -2 is -1, and -1 plus 2 would be 1. So, -2, 1, 0, 2, 2, 3, 4, 4. Okay. Now, if you had, say, y equals 1/3 x plus 4, then your multiples for your table would be -3, 0, 3, and 6. If you had y equals 1/4 x plus 2, then your values would be -4, 0, 4, and 8. So whatever that denominator is, those are the multiples that you're going to be choosing here for your domain or your x values. Okay?